Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The starting material is a cyclopentane bearing a gem-dimethyl group at C1 and N, CN3, 2 diazide amine, I, a tertiary amine equivalent, at C2, wedge, H at C3, wedge, and D at C3, dash. The two reaction pathways represent Hofmann elimination and Cope elimination respectively, both of which are stereospecific eliminations. Moving on to the next step. The nitrogen substituent N, CN3, 2 is actually better read as N, CH3, 2, a dimethylamino group, common in Hofmann-Cope elimination problems. The nitrogen at C2 is on a wedge, beta up phase. At C3 H is on a wedge and D is on a dash. Moving on to the next step. Hofmann elimination. 1. CH3I quaternizes the amine to give a quaternary ammonium salt. 2. Ag2O converts the iodide to hydroxide. 3. Heat, delta, causes E2 elimination. Hofmann elimination proceeds via an E2 mechanism, which requires antiperiplanar geometry between the leaving group, NMe3, at C2 wedge up, and the beta hydrogen being removed. For antiperiplanar elimination, the H or D at C3 must be anti to the nitrogen leaving group. The nitrogen is on the wedge, up, at C2, therefore the antiperiplanar hydrogen at C3 must be on the dash, down, phase, which is D. Thus, D is eliminated anti to the leaving group, giving a product where H remains on the double bond carbon, the vinyl H is H, not D. Product A has H at the vinylic position, no D in the alkene. And for the final step. Cope elimination. 1. H2O2 oxidize the amine to an N oxide. 2. Heat, delta, causes SYN, CIS, elimination via a 5-membered cyclic transition state. Cope elimination is a SYN elimination. The N oxide at C2, wedge, up, removes a SYN periplanar hydrogen from C3. The SYN hydrogen at C3 is on the wedge, up, phase, which is H, not D. Thus, H is eliminated SYN to give product B, and D remains on the double bond carbon. Product B has D at the vinylic position. Product A, alkene with H, no D, at the new vinylic position. The structure shows H and H at the double bond end. Product B, alkene with D at the new vinylic position. The structure shows H and D at the double bond end. This matches option A is equal to 1 dimethylcyclopentene with H, H and B is equal to 1 dimethylcyclopentene with H, D. Why other options fail? B reverses A and B incorrectly. C. Both show H, H ignores stereospecificity of Cope. D. Both show H, D ignores stereospecificity of Hofmann. Therefore, the correct answer is A. Therefore, the correct answer is option A.